Alright, now let's look at confidence intervals for unsample proportions. Alright, the concept is the same. The formula is just reflects a different notation. So your confidence interval will be the sample proportion, right? Will be your point estimate, the middle of the confidence interval, plus or minus appropriate z-value, and the z-values will be the same way as we'd work out the z-values for the one sample averages, times the standard deviation, which will be sigma hat sub p hat. Okay, the notation sigma hat sub p hat means it's the hat on top of the sigma means the estimated standard deviation of the p hats. And that formula, sigma hat sub p hat, to reflect the average, the estimated value, is the sample proportion p hat times 1 minus p hat divided by the sample size n. Okay, and everything else is the same. So this type of problem is very simple. Okay, so all we need is sample size p hat, sample size n, sample proportion p hat, and a level of confidence. Okay, let's look at a problem like that. Alright, the one on the top there, 54 of 100 lunchtime customers at a fast food restaurant order a numbered meal. Construct the 90% confidence interval for the true proportion of lunchtime customers who order a numbered meal. Okay, very simple. Alright, just sample data. Alright, 54 out of 100, so let's do p hat. 0.54. The n is your sample size, and we want a 90% confidence interval for the true proportion. So 90% confidence interval for p, true proportion, p hat plus or minus 90% in the middle, so 10% together in the two tails, 5% in one tail, times the estimated standard deviation sigma hat sub p hat. From the beginning of this lecture video, 5% was found to be 1.65. We calculate the standard deviation, sigma hat sub p hat. It's p hat times 1 minus p hat divided by the sample size n. Alright, so p hat 0.54 times its complement, 0.46, divided by a sample size of 100. Okay, and then we do that calculation. So square root of 0.54 times its complement, 46, divided by sample size of 100, and that to 4 significant places is 0.4984. Alright, I'll go back to check myself. Alright, yeah, 0.4984. And now we're ready for our confidence interval. Alright, so our 90% confidence interval for the true proportion p of those people who order numbered meals is the sample proportion p hat 0.54. Alright, that's our best estimate of the true population proportion. It's about 50%. Plus or minus a z-value, 1.65 times the standard deviation, 0.4984. Let's work that out in Excel. So the 1.65 times standard deviation, right? It's 0.8224, and then we'll go 0.54 in the middle of the distribution minus the z times the standard deviation, and then we'll go 0.54 plus that. Alright, and our limits are 4 significant places, 4, 5, 7, 8, and 6, 2, 2, 2. Alright, so 4, 5, 7, 8. 2, 6, 2, 2, 2. And we can write a statement that we are 90% confident that the true proportion, right? When we say the proportion, we mean true proportion of customers who order a numbered meal is somewhere between 0.5478 and 0.6222. Alright, somewhere between about 46% and 62%. Okay, that's the end of that problem. Okay, now let's do another one of those problems just to show you how it goes. Of course, with all of these problems, if you should be able to try it yourself, so just pause the video at a certain point and do it before you see me do it. Alright, so this one, 12 students in a class of 70 are left-handed. Calculate the 95% confidence interval for the true proportion of left-handed people. Alright, it's very simple. 12 of 70. So sample, we're dealing with proportions. 12 out of 70, we'll work that in a second. Sample size is 70, and we want the 95% confidence interval for the true proportion P. So we'll get our sample proportion, plus and minus the Z with 2.5% each tail, so that there's 5% total in the tails, 95% in the middle, times the standard deviation, sigma hat, so P hat. Alright, let's do the P hat. So it's 12 out of the 70. Alright, 1714. The Z with 2.5% is the same as what we found at the beginning of this video, 1.96. Sigma hat's a P hat we need to calculate, square root P hat 1 minus P hat divided by N. Alright, the P hat 1714 times, well, let's not worry about calculating what the complement is right now. We can use the calculator to do that, divided by the sample size of 70. Okay, so let's work that out. So it's equal to the square root of the 1714, etc., times the complement, 1 minus 1714, divided by the sample size of 70, and our standard deviation is 0.4505. Four significant places. Okay, so we're ready for our 95% confidence interval for P. It's the sample proportion, 1714, plus or minus the Z value, 95% level of confidence, 1.96, times the standard deviation here, 0.4505. Okay, and let's work that out on Excel. So the limit will be, the up and down portion will be 1.96 times the standard deviation. So it'll be the 1714 minus Z times the sigma hat sub p hat, and it'll be the 0.1714 plus the z times the sigma hat sub p hat. Okay. So we're going about 8 or 9% up or down from the 17%. Lower limit of about 8% and upper limit of about 26%. It's a pretty wide interval, right? But to be accurate about this, to 4 significant places, it's 0, 8, 3, 1, 4. 0, 8, 3, 1, 4, 2, upper limit of 25.97. Alright, and the statement interpretation, we can say that we are 95% confident that the, again, true proportion of left-handers is somewhere between 'Alright, you do it as percentage, 8.314% and 25.97%. Okay, and at this point you can understand, since you have a feeling for this, that that's a very wide interval, and somehow we'd like to have that improved if we were going to use it for anything meaningful. Alright, clearly we know it's not a quarter of the population that's left-handed. Yeah, so the 17% could have been an unusual sample. To make an improvement of that, we'd have to have a larger sample. Okay, and that's the end of that problem, and I'll stop that video here.